Okay, in this video we're going to look at evaluating definite integrals using U substitution. And I'm going to show you two ways to do this. The first, which I'm going to call method 1, is the more traditional approach, the approach that most of you are probably familiar with. Once I finish solving it that way, I'm going to look at it from a slightly different approach, again using U substitution but in a slightly different way, and this will give you what I think is in some cases a better option. So let's look at the more traditional approach first. What we would probably do here generally is we've got this definite integral from pi over 4 to pi over 2 of this function 4 sine cubed x cosine x with respect to x. And we would probably rewrite this as an indefinite integral. I'm going to call it I. And I'm going to say let's let I equal 4 sine cubed x cosine x dx. We're going to solve the indefinite integral and then come back and use it to solve the definite integral. So here, of course, we can let u equal sine x, which is going to make du cosine x dx. And my indefinite integral now becomes the integral of 4u cubed du. And that, of course, is just u to the 4th plus c. And I substitute back in for u my sine x, and I've got sine x to the 4th power plus c. I can now come back to my original question. My original question, remember, was the integral from pi over 4 to pi over 2 of 4 sine x to the 3rd times cosine x dx. And now I know that the antiderivative of this function is sine x to the 4th power, and I'm evaluating that from pi over 2 to pi over 4. Nothing too difficult in this. I do my substitutions, and I get the sine of pi over 2 to the 4th power minus the sine of pi over 4 to the 4th power. And of course, the sine of pi over 2 is 1. The sine of pi over 4 is 1 over radical 2, which is raised to the 4th power. And 1 over radical 2 squared is 1/2, and 1/2 squared is 1/4. So this just becomes 1 minus 1/4, which gives us a final answer of 3/4. So that's fine. We can do it that way. Let's look at another option. I'm going to try the same question again, just doing it a slightly different way, which in this case I think is maybe a little more efficient. So what I'm going to start with is this. I'm going to go directly into this integral, and I'm going to say, let's let u equal sine x and du equals cosine x dx, exactly like we did before. The difference is I'm not going to need to create an indefinite integral. So I'm going to go straight to I now equals the integral of 4u cubed du. Now, we can't say that these are both equal to I because up here I is a definite integral, which is going to give us an answer which is going to be a number. And down here we've, at this point, got I as an indefinite integral, and the answer to that, of course, is going to be a function. So this can't be right. We need limits of integration. The problem is my limits of integration up here, pi over 4 to pi over 2, those are x values because of this dx here. So that means that down here I've got a du, I need u values up in here. This has to be a u, and this has to be a u. So what we're going to do is we're going to figure out what u values we want there. And so I'm going to say, well, u equals sine x. So that means that if x equals pi over 4 from up here, then u at pi over 4 would just be the sine of pi over 4, which is 1 over root 2. And if x equals pi over 2 up here, then I can say that the u of pi over 2 is just the sine of pi over 2, which is 1. And so those values come into here. So x being pi over 4 means u equals 1 over radical 2, and x being pi over 2 means that here u is going to equal 1. And now I can solve this directly. So this, of course, the antiderivative of 4u cubed is just u to the 4th, and I'm evaluating from 1 to 1 over radical 2. This is going to be much simpler than the last case because I can go directly in. 1 to the 4th is 1. 1 over radical 2 to the 4th is going to be, again, 1 over root 2 squared, which is 1/4. So this, again, is going to come out to 1 minus 1/4, and we get the same answer we did the last time. So we can do this either way. This approach is in some ways a little bit quicker, and you should be aware that sometimes on the advanced placement exam, they can create questions where you have to do it this way. So I would encourage you to learn both approaches. I hope this helped. Ask me if you have any questions.